So to give you a feel for what KSP values are like, we're going to take a couple of examples. We're going to look, for example, at galena. So galena is lead sulfide, PbS. And if we were going to write a chemical equilibrium, we could write it as PbS in the solid phase is galena, and that dissolves into lead ion, the 2 plus state. That would be an aqueous solution, and then plus sulfur ion, 2 minus, and also in aqueous solution. The solubility product for this would simply be the concentration of lead in aqueous solution, again with a 2 plus, which we'll just skip for convenience, and then sulfur ion, well, I guess we can add it, also in aqueous solution. Now, we don't need to look at the concentration of lead sulfide in galena, because if this solid is nearly pure galena, then that concentration would be equal to 1. That, if we wrote it with the reactants, it would be an equilibrium constant. But since what would be down here would essentially be equal to 1, 100%, we could skip that and write it as a KSP. So what is the KSP? Well, we can look it up online, which I have done, and it's listed not as a KSP, but as a PKSP. So the PKSP for galena is listed at 26.77. Remember, this is the PKSP is equal to the minus log of the KSP. So this is a matter of convenience here, but if we want to do any calculations, as we'll show in a later video, you really need this KSP value. So if we want to recover the KSP, we'd take 10 to the minus 26.77. This will give us the KSP value, and that is equal to 1.68 times 10 to the minus 27. So for that equilibrium that we drew earlier, where we have galena lead sulfide dissolving into sulfur plus lead ions, you can see that the amount of sulfur and lead that we're going to get out of this is going to be a very, very small number. Most of the lead and sulfur is going to be retained in the lead sulfide, which is very good news as a mineralogist, because if we're handling samples of galena, we really would not want a lot of lead dissolving into any kind of fluids on our hands or in our drinking water, etc., if we happen to be eating lunch while we're inspecting minerals. So that's kind of a good thing for us, at least for mineralogists. So how about if we compare this to the mineral anglicite? The mineral anglicite is also a container of lead. It's a lead sulfate, PbSO4. How would its solubility compare to galena? And this is where the KSP values become very handy. If we drop a piece of anglicite into water, would we get more lead or less lead? Which one would provide more lead into a glass of water, or somebody's drinking water for that matter? Well, anglicite, it would dissolve into lead ion and sulfate ion in solution. So we would have lead in aqueous solution and then sulfate in aqueous solution. And the KSP for this, well, we don't get the KSP directly from the tables. We'll get the PKSP. It's listed as 7.79. Both of these values are for conditions of 25 degrees centigrade, by the way. If we change the temperature, then these PKSP values would be different. And so we will take, to get the KSP, we'll take 10 and raise it to the minus 7.79 power, and we would get equals 1.62 times 10 to the minus 8. Now that's still a very, very small value, but take a look at its comparison to 10 to the minus 22. If we have a cup of water, so let's draw a little cup of water over here, and we put in a piece of galena, and then over here, let's say on the other side, we put in a little bit of anglicite. So the anglicite is shown there, and then the galena is this fellow there. The anglicite is going to donate a lot more lead to the water than the galena will, considerably more, because this KSP value is much, much greater than the value for galena. So we can make these comparisons to see which kinds of minerals will donate more of a certain kind of ion. And of course, we can do very specific calculations as well. So we can use this in a qualitative way or sometimes in a quantitative way. So this is one way of using PKS p-values. Here we're just taking a quantitative look. In another video, we'll show you how to do some precise calculations to estimate the concentration if you have a system that is saturated in a given mineral.